And the topic for today is going to be layer 2. So in layer 2, we are going to see topics such as VLANs, we are going to see topics such as trunking, then we are going to see inter-VLAN routing, then we are going to see something like VLAN trunking protocol, then STP, and then Ether channels. Okay, these are going to be our topics that we will look into. So today, probably we will see VLAN and trunking, and let's see how it works. Now, if I let me give you an example. So if I take a switch here, and then that specific switch is connected to multiple devices, right? And then this particular devices are configured with a network called 192.168.1.0/24, where 1.1 is here, 1.2 is here, 1.3, 1.4, 1.5, and 1.6. This is how the IP addressing has been assigned, right? So they all are sharing the same network and they should be able to communicate together. But what if we have a scenario like same, but let's say that the devices are grouped together from different organizational departments. Okay, so let's say this 1 and 2 belongs to sales department, this 3 and 4 belongs to marketing department, and this 5 and 6 department belongs to HR department. And we do not want the communication between these departments to be done with each other. Make sense? So the sales department should not be able to communicate with marketing department and should not be able to communicate with other department as well. So interdepartment communication should not be done. Now, if we just implement such scenario by just keeping different networks together, because what we are looking forward over here to do is by like keeping them into same network and then creating different, I would say, VLANs. Okay, the thing that we're talking over here belongs to VLAN, which stands for virtual LAN. And this virtual LAN means that physically you would be connected with just single local area network, but virtually there are multiple, I would say, logical broadcast domains that will be created. So if you have a scenario like this, let's say that I give you a scenario that says you have one PC, or I would say one switch, then you have other switch. Let's say this is switch 1, this is switch 2, right? And then you are connected with another switch called switch 3, and then switch 4, and then you are connected to some router. And this is how the connections are made, right? And then you have a couple of PCs, that is A and B, and these PCs have some IP address 1.1 and 1.2. Now, if all these switches are new, correct, these are newly installed network. So whenever the A and B wants to talk with each other, they can communicate through this switch 1, correct? Now, what's going to happen is there is going to be other devices as well that's going to be connected. So switch 2 has this user called C, switch 3 has this user called D, switch 4 has this user called E. Okay, and they all might be using different networks. So if I ask you guys that whenever you have specific VLAN information, that I do not want people from this department, or I would say connected to same switch, even though these people C, D, E and all have same network, let's say 1.3, 1.4, 1.5. So if this, now how many collision domains do we have over here? We can say that 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have 9 collision domains and we have one broadcast domain. This is how big a broadcast domain is in this network. Correct? So the communication can happen from here to here to here to here, anywhere in between this, right? As long as the broadcast domain is that big. Because router is the one who divides the broadcast domain. Switches share the same broadcast domain over here. Makes sense to you? So if we want to divide the communication between here, 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 and here, then we will keep this particular part in different VLAN. Let's say VLAN number 10. And then we will keep this as VLAN number 20. And this as VLAN number 30. And this as VLAN number 40. Makes sense? So 10, 20, 30, and 40 cannot communicate with each other. This is not possible. That's how VLANs basically, because VLANs create logical broadcast domains. Do you understand that? Do you understand what VLANs does? VLANs basically create logical broadcast domains and they divide networks logically together. Okay? Physically, the networks will be same, but logically they will divide it. Now, I will ask you one thing. If we compare VLANs versus subnetting, okay, if we compare VLANs versus subnetting, and let's say that I'm not using this one same network here. If I use an IP address that looks like this 2.1, 3.1, and 4.1, am I achieving the same thing here? That I do not want these people to communicate together. So, can I achieve the same thing by using subnetting? You can achieve the same thing by using subnetting as well, right? Then why would we choose like what is better to use? Can we use VLANs or can we use subnet? What is better to use? What's your take? And if you think that VLAN is better, then please state the reason as well. Okay, so let me give you a broader picture on why would we prefer using VLANs over subnetting. You see, what happens is, do you remember we talked something about unknown unicast flooding? Do you remember this concept? We talked about this on probably very early days of our training. And what this unknown unicast flooding does is whenever there is any query, let's say that A sends a traffic and that traffic needs to be delivered to B. So our source is A and our destination is B, correct? They will have some MAC addresses as well. Now, whenever switch 1 receives that specific traffic, then how does switch performs it or how does switch reacts to it? Switch is going to see in its MAC address table whether does it know about A and B or not. If it doesn't know about A, then it will add the information of A into its MAC address table, right? That A is connected to, let's say, 0/1, correct? And what will it do with B? B's information is not there. So how would it react to it? Then this particular switch is going to flood all the information on all of its ports except the port that it received the information on. Correct? So it's gonna send this over here, and the switch 2 will again send it over here, and switch 3 will again send it over here and over here and over here and over here. Do you get that? Makes sense to you? So this is what is it's going to be. And as this unknown unicast flooding is a complete layer 2 flooding, it doesn't see the information whether this network is using 2.0, 3.0, or 4.0. Okay, the flooding doesn't check the information as it's a layer 2 flood, okay, or layer 2 kind of flooding. It doesn't check the information whether it's going beyond its network or not. Makes sense there. That's why it creates if you use subnetting like that, And switch will not then consider that if it's using 2 or 3 or 4, the messages will go there on all the ports that it has. So that's why if you use VLANs over there and you can divide this networks accordingly into different VLANs, your layer 2 flooding will not cross the VLAN information. Make sense? Your layer 2 flooding will stay there for the same VLAN. Okay, and unnecessary ports will not receive that unnecessary traffic, saving a lot of bandwidth. So that's why VLANs are preferred over here than subnet. Okay, that's one of the major reason that we use VLANs for. Okay, however, it also gives you security and it also gives you better management of your domain and all. So all those additional perks are there, but this is one of the most important thing that you should consider why it gets used. Make sense? I hope you understand that. Perfect. So we're going to see this VLAN in action. And I'll just share my packet tracer screen with you and then you can see that. So I'll just add a switch here, a normal 2960 series switch. And I'm gonna create and connect multiple PCs with it. So let's say I'll take around 6 PCs for 3 different departments. And I will make these, I would say, departments as part of different networks. So we will take one as green. All right, we will connect these different PCs together in different networks. Cool. We will say this is going to be VLAN 10 for sales department. The second one is going to be VLAN 20 for marketing department. And we're going to create VLAN 30 for HR department. Do you understand that? That's how we're going to create these. Good. Then we will go ahead and assign it some IP addresses there. So I'm going on PC1, desktop, IP config, and say 192.168.1.1 tab. There is no gateway information that needs to be configured, so that's all fine with us. Then I'll go to the second PC and say 192.168.1.2 and tab. And then say the third PC, 192.168.1.3 tab. 192.168.1.4 tab. Desktop 192.168.1.5 tab. And then desktop and say 192.168.1.6 tab. You get that? So we did configure it, our major network with 1.0 network. And if I try to send traffic from first PC to second PC, successful. From first PC to third PC, successful. From first to fourth, or last, it's again successful probably. There you go, it's successful. So every PC it's communicating with each other over here, correct? Because what happens is by default, each and every switch port is a member of VLAN 1. I'll just hover my cursor on my switch and you can see the information inside this table that the third column in this information that you can see, it belongs to VLAN column. And you can see our fast Ethernet 0/1, 2, 3, 4 throughout 24, and the last, even last, I would say couple of interfaces that are gigabit Ethernet interfaces. They are also part of VLAN 1. Do you see that information? Yeah, so by default, every switch port is part of our VLAN 1. Okay, and we move the membership by creating multiple VLANs there. Okay, and then we basically assign the member or assign the ports to those newly created VLANs whenever we create them. So on this switch, what we are going to do, we are going to create 3 different VLANs and we are going to name those VLANs according to the departments. And then we will make these ports as member of those VLANs. And how are we going to do that? We'll just access our CLI. So we will go on to the CLI mode of our switch and then we will see enable. It's going to be the first command, conf t, and I will name this particular switch as hostname space SW1. So we're going to name the switch as switch 1. And then after that, by going into the config mode, we can create multiple VLANs by using just a command called VLAN space. You can use the number anything between 1 to 4096. Now there is another thing I would say, okay? There are different sections of VLANs that you have. So VLAN 1 is called as default VLAN. Okay, and it is non-manageable VLAN. You cannot basically manage this particular VLAN. Okay, it is by default created and every port by default is a member of this default VLAN. Cool. Then you can create VLANs from 2 to 1001. Okay, and these VLANs are called as standard VLANs. Okay, these are used for normal users. Makes sense? So you can create any VLAN from VLAN number 2 to 1001. And then there is VLAN 1002 to 1005. These are called as reserved VLAN. Okay, and not for use purposes. And then there you have extended something called VLAN from 1006 to 4094. Okay, and these are called as extended VLAN. And these VLANs are used for purposes like voice, okay, wireless, or other traffic. So the number of VLANs that we're going to deal with is the second one, from VLAN number 2 to 1001. Okay, looking into the other VLANs is not part of our content as of now and none of our concern as well. So VLAN 1 is the by default created VLAN. We are going to deal with these first 2 VLANs, the default VLAN and the standard VLANs. Now the 10, 20 and 30 do sit in this particular range from 2 to 101. So we will just create those VLAN and see how they look into the VLAN database. So I'll just go on this particular switch, and in order to create this VLAN 10, I can go to config mode and I can say VLAN space 10. And that is exactly how easily you can create this specific VLAN. Okay, so VLAN 10 has been created just by using this VLAN command. And then you can see that the mode has been changed from config to config VLAN. It means that you are inside of that VLAN config. And inside of that VLAN config, you can change the name of that VLAN as well. So you can name that specific VLAN by using a name command. And you can mention the name as well over here, that name space sales. And you can hit enter. Okay. You can take anything between 221.0.0.1. Okay, I just took randomly that 10, 20, 30 like that. So I created VLAN 10 and said name sales. And then I can take an exit and I can check the information inside my VLAN database as well by running a command called, in the enable mode, I can say show VLAN brief. This is the command that I can use in order to check the database of the VLAN, that how many VLANs do exist in my VLAN table. So you can just go ahead and check the configuration by using show VLAN brief command. And upon you hit enter, you can see that these are the number of VLANs that are active as of now. So you have VLAN number 1, okay, and the name of that specific VLAN is default, and you can see that the ports that are member of this VLAN 1 are these, starting from FA0/1 till FA0/24, and then the gigabit ethernet 1 and gigabit ethernet 2. Do you understand that? And you can see that we did create a new VLAN as well that has a number VLAN 10, and the name that we assigned is sales to it. But there is no member as such. So we'll talk about that. But first, let's go and create the other two VLANs as well. So we will go to conft mode again, and we will say VLAN space 20, and then I will name it as marketing, and we will take an exit and then again create VLAN 30 and say namespace HR, and then take an exit. Good. Then if we run that command from config mode, we will say do show VLAN brief, and you can check that by running in this do show VLAN brief, you can see that all these three VLANs are created now. Do you understand that? Then you can see that this 10, 20 and 30 are created, but still there is no port assignment, because if I still send any traffic from PC1 to PC3, then it's still being successfully delivered, or any host can talk with each other. Because we have, however, created three different VLANs, but we haven't assigned any members, or we have not made the membership there. You get that? So, because by default, all these ports are still member of this VLAN number 1. So what you need to do, you need to take this first PC that is connected to FA0/1. You can see that over here. That is FA0/1 and FA0/2, that these two PCs are connected with. Correct? So I will take this FA0/1 and 2 and shift their membership from VLAN number 1 to VLAN number 10. Then I will take next two interfaces, that's FA0/3 and FA0/4, and make them a member of VLAN number 20. And then I will take switch interface number FA0/5 and 6 and make them a member of VLAN number 30. So how do we do that? We go inside of this particular interface. We take interface, the first interface is FA0/1. We go in that interface and we use a command called switch port access VLAN 10. This is how you assign it to a specific VLAN. And that's done. And then we can go and say interface FA0/2, which is the second interface now, and make it a part of VLAN 10 by using a command switch port access VLAN 10 and take an exit from there. It's that easy. So you can also check by running a command called do show VLAN brief. You would be able to see that now both of these ports are now member of VLAN number 10, and they have loosened their membership of VLAN number 1. Do you get that? So by using these commands, you can actually get to know that FA0/1 and FA0/2 are part of VLAN number 10 now. Just like that, you can select now. It is possible that you might have multiple interfaces that needs to be put in a specific VLAN, right? So you can use a range command instead of that, like individually assigning the IP address, individually assigning the interfaces to the VLAN. And then I can use a command called interface range and select a range or a pool of interfaces that you can select. So I would say interface space range space, FA 0 slash 5, sorry, 0 slash the next two interfaces 3 hyphen 4. So you can select interfaces like that as well. That interface range FA0 slash 3 hyphen 4. And then hit enter, and then you can say switch port access VLAN 20. Makes sense? So in one command or in one go, we assigned two interfaces, FA0 slash 3 and 4 to a VLAN. If we have selected interfaces like FA0 slash 10 hyphen 20, then we are doing nothing but assigning around 10 interfaces to a specific VLAN. Okay? But if you want to select multiple interfaces that do not come in a range, okay, or they are kind of individual, so how would you do that? You would basically select interfaces like interface range FA0 slash 5, and then you can use a comma and mention the other interface. In our case, it's just the next interface, so I'll say FA0 slash 6. You can either use FA0 slash 5 and FA0 slash 10 or 15 like that as well. Okay. And then I can say switch port access VLAN 30, make them a part of VLAN number 30. Cool, that's exactly how we do that. And then you can take an exit, and you can see that do show VLAN brief. And we have assigned these three VLANs, that different VLANs. Okay, that the interfaces that needs to be part of them. And once you are done doing this, then you can check that if the configuration works. So from PC1 to PC2, the communication will work. From PC2 to 3, sorry, 3 to 4, it will work. And 5 to 6, it will work as well. But if I try from 1 to 3, it says failed. And if I try from 2 to 3, it fails again. If I try from 1 to 6, it fails again. So you see, communication from different VLANs is not possible over here. Only people from same VLAN can talk with each other. However, the IP network is just same. They are still in the same IP network, that is 192.168.1.0. Makes sense to you? So that's what the thing is over there. Perfect. Go ahead, do this lab and let me know when you're done. All right, guys. I hope you all are done with this particular lab. Then what we are going to do is we will just shift this particular topology a bit. Like this. And then we will create another topology with another switch here and couple of PCs. And then we connect these. We will need some other PCs as well. So we have more two PCs, and I would say these PCs are again part of VLAN 10. That's going to be sales VLAN. Okay, and then you're gonna have VLAN 20 over here as well for marketing, and you're gonna have VLAN 30 as well for HR. The same set of VLANs that you have on switch 1. So you're gonna create the same thing over here. Okay, we will just go ahead and configure the same. We'll say host name as switch 2, and then I would go and create three VLANs. VLAN 10, name them as sales. Then I will create VLAN 20 and say name is marketing, and VLAN 30 and name it as HR. You get that? Then after that, I will select the range, interface range FA0/1 and 2, and make it as switch port access VLAN 10. Okay, then I'll select interface range FA0/3-4 and make it as member of 20, and we will say 5 and 6 and make it as member of 30. And then if we check the VLANs by looking into information do show VLAN brief, you can see that all my VLANs are created on this as well. So go ahead, create a replicated image over here as well, and then we will connect this switch 1 and switch 2 together and see if communication happens or not. So go ahead, do this topology as well. Meanwhile, I assign this IP address, and we will keep the IP address in the same network. So 192.168.1.7, starting from 7 to the second PC, we will give the address as 8. The third PC will have an address of 9. Then you will have a PC that has an address of 10. Then 11. And the last PC has the IP address of 12. And that's all. Do this config and let me know when you're done. All right, so when you have communicated over here, if I just try and attach this cable together now, because communication from, I would say, here to here would be successful, then from here to here as well would be successful, and successful here as well. But if I try to communicate again between the VLANs, it will not be possible. And also, if I try to connect this switch with this switch, then the communication there as well will not be possible if we try to send this traffic from this particular VLAN 10 to this over here on VLAN 10. It says it is failed. Do you get that? And why so? Because your FA0/7 is basically a part of VLAN number 1. Can you see that in the box? In FA0/7 or on our switch 1, the FA0/7 is still part of VLAN 1. And on switch 2 as well, if we try and see that our FA0/7 is a part of VLAN 1 as well over there. So your interfaces FA0/1 and 2 are taking traffic from VLAN number 10, and they cannot send traffic through VLAN number to VLAN number 1. That's why the communication is being failed over there. Do you understand this logic? Why the communication will not be possible over here? Perfect. And for the same reason, you need to make this particular link as a trunk link. And what do we mean by trunk link? So there are two types of ports that a switch has. One, you have an access port. An access port basically is member of one VLAN and can talk with only that VLAN of which it is a member of. Correct? Meaning that if your FA0/ I would say 7 is a part of VLAN number 1, then it will only be able to communicate with the VLAN that it is member of, like VLAN number 1 itself. And then second type of port that you have is a trunk port. Okay, and trunk port is member of no VLAN but can talk with all the VLANs. Do you understand this? And access port is the default port basically. Whenever you turn on a switch, all the ports that a switch has are part of an access port. Okay, so you need to make your port a trunk port, then it will lose its membership of VLAN 1. The FA0/7 will lose its membership of VLAN 1, and it will only be able to communicate with the other, like with all the VLANs. So we will do that over there. We will go to switch number 1 and we will go into enable conf t and say interface FA0/7. And then to make it a trunk port, the command is switch port mode trunk. And you apply this command and then you go on the second of switch and say enable conf t interface FA0/7 and say switch port mode trunk. There you go. The interface will go down and it will come up again. So it will restart the interface, and then you can use this fast forward button in order to forward the simulation by 30 seconds, and you can see that the interface is up now. If I show you that your FA0/7, can you see now there are double hyphen in the column of VLAN? You get that? So your FA0/7 is no longer a VLAN of or no longer a member of VLAN 1, and it is no longer a VLAN of member of any VLAN. So it is acting as a trunk port. The command that we used is switch port mode trunk. Simple command there. You get that? That's how it works. And then if I just go ahead and try to send traffic from this 10 VLAN to the other 10 VLAN, the traffic is successful now. If I try to send traffic from 20 to 20, it's another time successful, and 30 to 30 successful. Makes sense? This is how a trunk works. Okay. So go ahead, do this particular lab and let me know when you're done. All right. I hope you are done with the lab. So that was how our trunk can be configured. So that is what trunk is, and that is what VLANs is. Okay, we talked about today, and that was our content that we had to cover today. Okay, quite early, but yeah, this was the content that we had to cover. Yeah, the trunk basically uses a protocol called .1q in order to do the configuration. So whenever if you are asked that what is the protocol that trunk uses, then it uses .1q. Okay, there is other protocol as well called ISL, which is called as inter-switch link. Not SSL, it's ISL, inter-switch link, which is basically a Cisco proprietary, but we do not really use that. Okay, so by default, .1q is going to be the protocol that will be used. Okay, we'll talk about certain other things of trunking and negotiation and how it works in our next session. And in tomorrow's section, we are going to discuss about inter-VLAN routing along with some other details of trunking. So that is all that we had to discuss today. I hope you enjoyed the session. Thank you so much for tuning in, and I'll guys see you tomorrow.